All right, all right. Welcome everybody to Trino Community Broadcast number 45. We're rounding up on that 50 number here shortly, and today we have a special set of guests here. But first, before I hop onto them, I will first introduce my my partner in crime, Cole Bowden. How's it going, Cole?
Hello, glad to be here. This is the first community broadcast I've been on in a little while, so happy to
Yeah,
be
I
back.
know. Where were you, man? Were you like ducking out, or were you sick, or what was going on?
There was one where I had the flu, so
Yeah.
yeah, it
Yeah.
happens.
It does happen. It's unfortunate, but it's that time of year where it's like, you get with a bunch of sick people inside the doors all the time, and it's cold and it's hot and it goes back and forth, and yeah, everybody gets sick. So never fun, but glad that you're feeling better now and here with us today. So yeah, this go around, we're going to be actually talking with a community that a whole separate community that is on the other side of the world of us, and we always really like these kind of global reaches that we can do. So we're talking today about workflow orchestration. A lot of people, when they think of workflow orchestration here in the United States, they're commonly thinking of Airflow. That's the kind of incumbent system that a lot of people are using these days. But there is a lot of times where there's a lot of newer kind of innovation that's needed. Sometimes there's other kind of needs that are had, particularly around trying to kind of federate or make the ability to interact with these systems a lot more applicable to end users and bring the interaction capabilities to people that are actually, maybe using the data rather than defining pieces on the data. And so we're going to get into this project called Apache DolphinScheduler. Here today, we have a whole bunch of the folks from this project joining us today from China. And I'll start with you, picking on you, William. What time is it over there right now? Just so everybody has a feel for the level of dedication you all have to joining us today.
Yeah, now I think it's 1 a.m.
It's 1 a.m. in Beijing. Okay, yeah. So we have me here in Chicago time. It's actually a pretty good hour for me. It's 11 a.m. Cole, it's like 9 a.m. for you. 1 a.m. in Beijing time. So and that's pretty much for everybody else here on the call. So William, what do you do in the project? How are you associated with DolphinScheduler?
Yeah, actually, I'm one of the PMC of DolphinScheduler, and I also is Apache Software Foundation member.
Okay.
And I used to work at Teradata, IBM, Lenovo, and so on. I worked for in big data area for over 18 years.
Awesome. Wow. That's crazy. Yeah. I mean, I've been in software for almost over just hitting a decade. So I'm like halfway where you're at, but I started in big data. So I can almost say I have a decade of big data experience. Yeah, for sure. So thanks for joining us today. Next, I'll pick on you, David. What do you do in the Apache DolphinScheduler project?
Hello, everyone. I'm David. I'm an Apache DolphinScheduler PMC chair. I'm also Apache incubator mentor. I mentor some projects like Link's Huge Graph and some other projects. I'm been working in big data area for more than 10 years.
Nice.
I'm also open source project fan. I love open source culture very much.
Yeah. I think you're in good company here, David. We're all big fans of open source as well, and so I think that's a nice background list. You're the actual chair of DolphinScheduler, so you're the top, right? you're the okay. So going on to the next, Nico Zhang, you're the person that I interact with the most because you do a lot of the community things in Dolphin Scheduler. So what do you do? And give yourself a little introduction.
Okay. Hi, everyone. I'm Nico. I'm the advocate of the Apache Dolphin Scheduler community. It's been a pleasure to meet Brain. It's been an honor to be working with the Trino community on this broadcast. I hope you have enjoyed. If you are interested in Dolphin Scheduler, please contact me on Slack. Okay,
Amazing.
Thank you.
Awesome. Thanks, Nico. Thanks for hanging out. And then to finally, last but not least, Jay Chung, how are you doing? And what do you do with Dolphin Scheduler as well? Jay, are you there?
Jay's looking a little
frozen. Yeah, looks like we may have lost Jay. So hopefully we'll get him back in a second. But Jay, are you there? Can you hear us?
Sorry, my network is crashed that half. Yeah.
No worries.
Yeah.
I can hear you now. Feel free to introduce yourself.
Yeah. Hi, I'm Jay Chang, and I'm also the Apache Dolphin Scheduler PMC. I work for software engineer for almost 6 years, and I have 5 years in data engineer thing. Yes, and also I love the open source project. I every day spend mainly my time in the PR review or the issue review. Yes.
Awesome.
And, yeah.
Awesome. Great, Jay. And we're going to be hearing a lot more from you later during the demo. So excited to see the demo that you've pulled together with Dolphin Scheduler and Trino. So,
Yeah.
Okay. Well, without further ado, let's go quickly into Manfred last 2 weeks ago on the last episode, or is it 2 weeks? It's like 3 weeks ago. Oh no, it's been actually almost a whole month now. So about a month ago now, Manfred did a recap of Trino in 2022. I wanted to kind of hit some of these top level pieces before we get into the meat and potatoes of this week's or this episode. And so recap in 2022, we have a blog that we wrote that details full feature, all of the things that have kind of happened. So, a lot of statistics and kind of high level things that have gone on in the community over the last year. Some trending moments that we had. So we went out with the Leaving Facebook post and had a really good success with getting some awareness around the project with that. So, really kind of pushing all of you folks that are on Hacker News to share anytime you find a post that we have that's interesting, and all sorts of other things, including, Trino touching the world. We wanted to kind of give a sense for, kind of our top users, and surprisingly, not, or maybe not surprisingly, in third place is where China sits with 31,000 users that are visiting our site. These are site numbers and number of individual IP addresses that visit the Trino website. So this kind of gives a sense for the size of the community in each of these locations. And so China is definitely one of the powerhouses of Trino users. And so this is why I think it's particularly exciting that we are growing, kind of the associations with different projects that are like Dolphin Scheduler that are very popular in particularly in a China user base. So this is really exciting. In the same way, like we want, a similar kind of thing. There's a good chunk of users that are using Dolphin Scheduler today in the US, but we want to grow that on both ends. So this has become, kind of a really exciting overlap of our two projects that we have here. So definitely check out this link here that kind of brings you to the Rabbit Reflects URL, and we'll talk about a lot of these features like merge supports that we added this year, JSON functions, the polymorphic table functions. Actually, Cole, you did a Trino community broadcast a while back now on that, and so dive into a lot of details there. Obviously, the big one, fault tolerance execution, that was quite a, I would say, a pivot point kind of feature that really changes like a lot of the use cases that we can now support in Trino, and so and many more. So definitely, if you are wanting to look at what happened with Trino last year and kind of get excited for all the things that came down, check out that blog. One of the other things I want to quickly highlight, Trino Definitive Guide came out with a second edition, and not only that, but second edition in the Chinese translation will be out later this year. I think it's going to be probably June or July, and there will be a Chinese translation available that anybody who's watching here will try to basically make it available to anybody who's kind of learning about us through the Dolphin Scheduler thing. We'll make that Chinese edition available shortly. And then one final point I wanted to make in the Trino here. Let me bring over my. So if you go to the Trino Slack channel, if you join the Trino Slack channel, we have these different rooms or different channels, and particularly there's ones that begin with the tag general that have a dash and a kind of language pointer. So this is our general in room. Basically, anybody who wants to talk to other Trino users that speak the dialect of Japanese. We also have a let me see. I think was it Korean one that we just opened up. And let me actually just go open up. Let me see if I can join. What do this recently just changed, and and let's see. There's create. I want to join. There's a manage. I want to see browse channels. There we go. All right. So let me look for all the general channels.
I believe we have Chinese, Japanese, German, and Korean.
So those are our current ones. If there's a kind of community of users that speak a whole different language, please let us know. So currently there's Chinese, Japanese, and I highly recommend anybody who's watching on this that wants to join to hop onto the Chinese channel. We already have 103 members there. And then there's the German channel and Korean channel. So we're building these out on a demand basis based on like what anybody that wants to, but we just wanted to actually showcase that to make sure that if you want to kind of ask the users in this space that maybe speak the local dialect to make things easier for you, those are available for you as well. So without further ado, before we hop into the content of this episode, let's quickly jump into the release that just happened. Cole, do you want to kind of give us some of the high-level features that came down the pipe in this release?
Yeah. So there were some relatively big changes. The release took a little while because of a few different blockers that slowed it down, which means that we got a lot more changes in this release than we normally would. This includes several large performance improvements. Some for highly selective queries is the way Martine summarized it, which I appreciate because you can see like small concurrent queries run on large clusters is the actual note written. So performance improvements. Tons of performance improvements from reading for Parquet across various connectors. We added the query pass-through function to the Cassandra connector, so you could now push down entire queries for Cassandra to run natively, which was the topic of that polymorphic table function episode we did before. An unregistered table procedure in Delta Lake and Iceberg, and also support for writing to the change data feed in Delta Lake. So it used to be that the CDF was only automated, but now in case there's something you want to modify or edit or adjust, you can go ahead and do that.
Nice.
Which is a pretty big deal. And there's been more improvements to that coming down the line in 408. I think that shipped with a couple snags that are being addressed. So
cool.
Stay tuned for that to be even better come next version. In my opinion, definitely not because it was my PR. The most exciting change was that we added an action to Trino contributions, where when pull requests go stale, a bot now will comment. It'll ping me, it'll ping Brian, it'll ping Manfred, and the three of us will swoop in and try to get things rolling again. So.
And I started doing that yesterday, actually. So we got tagged starting over the weekend, actually, because I think David merged it over the weekend.
We got
And
tagged on the Monday holiday, is what it was.
on the Monday holiday,
Yeah. It only tags us Monday to Friday. We don't get pings.
Oh, good.
But it doesn't know about President's Day.
So there was a huge influx of tags that we got on Monday, and we happened to be on holiday that day. But then I went back and I just I went through all the notifications yesterday and started reaching out, getting things moving. And we've actually already had some PRs merged that were supposed to be merged, but we're just kind of oh, somebody missed something real fast, or they thought that they were waiting on something, but they actually weren't. Then we had a couple that were hey, this actually got solved by something else. Let's close this out. So what the holy grail of what we're trying to get with this whole thing is we actually did a lot of backlog sweeping and cleared out a whole bunch of the really old and stale ones and communicated with people directly about that. We didn't do it in an automatic way like you see a lot of projects do. We really actually went ourselves one by one. And then the next part is the next phase of this is to have keeping this down from the 500 to 600 we started with.
700.
Now it's kind of 700 PRs. Now we're down to 350. So we literally cut that in half. We're trying to get to a point where basically what's left, ideally we'll be looking at somewhere around 200 to 250 of PRs that will actively be worked on at a time, at least at our current state. And basically, anything that's kind of stuck or postponed or anything like that, those will get kind of, closed temporarily. And then eventually over time, you can reopen those whenever there's active work being done. And this just makes, things a lot easier from the maintainer perspective of where should I be focusing my time and energy on right now? And that will actually improve the performance and how quickly we can get things out. And rather than things kind of just sitting stale for a long time.
Yeah, and so for a Trino end user, the question is what's the big deal? And immediately there's not going to be a massive payoff, but in the long term, this will make Trino development a little faster, a little more efficient, a better experience, and I think it will improve Trino long term in subtle ways, but definite ways. So
yeah, totally.
I'm excited about that.
Quick shout out from Manfred. He's the third of our DevRel team, but he just wanted to say thanks to everyone on the DolphinScheduler team for joining us so late at night. So again, thank you again. Okay, let's continue, Cole. I interrupted you with my whole soapbox about how excited I am about stale.
It's a good soap. I'm excited too, Brian. So
yeah,
I don't mind. We could talk about that for an hour if we really wanted to. We're not
not.
Next fix. There was a fix to Kerberos on the Kudu connector. I looked at it when we got fixed. It was surprising to me that this had existed the way it had for a while, where the issue was Kerberos issues authentication tickets. And then when those tickets expire, it should renew or move on to new tickets. And it wasn't. It would just hold on to the expired tickets and then error out because it wasn't authenticated or validated anymore. So you couldn't run the Kudu connector for more than 24 hours. And now you can't. So you don't just need to restart Trino or restart Kerberos every time you're running the Kudu connector for long-running jobs. It can just go, which is a massive usability improvement. I'm not sure the Kudu connector is our most popular is probably the answer to my question of how this existed.
I was just about to say that actually.
Not a ton of people who were going to run into that, but if that was why you weren't using it, it's gone now, so you can go ahead. And then finally, there were a ton of sophisticated performance improvements. We added 6 new configuration values so that you can use to fine-tune Trino performance with remote task split size and minimum task size, default task size, which was fun to read, going over it to try to figure out how I wanted to document it, because several engineers were discussing okay, what are our arguments for setting these as defaults, how does this perform on certain benchmarks, what's the deal, is this worth it? And the answer is, well, yeah, they got there, but it also is just interesting to watch the process of how we make Trino go that much faster, squeeze that much more speed and performance out of this engine. So
Yeah, and we've said it a million times. Like it's always these very small aggregate like changes that aggregate into something much bigger. But like those small changes are things that like are very like it feels minuscule, but it's something that we obsess over in terms of getting it right as we're going out on those. And
yeah,
it's you just look at any of the things tagged in with performance or has performance in the title, and you'll see a long debate about how it's done.
and when you have 1% change, you know that's not going to revolutionize the user experience.
Yeah.
But when you do a 1% change every release,
Yeah.
or a couple of them every release, 101% changes, and suddenly you're twice as fast. So
Yeah. Yep. Exactly. Cool. Well, anything else you wanted to cover on the release before we hop into the concept?
I think that about covers it. So let's
All
get
right.
back to
the
Dolphin
concept
Scheduler.
of the episode. All right. Well, so I think that what we really want to get to the heart of, I mean, before we dive into any specifics, like I think that most people are pretty familiar with workflow orchestration. Anybody who is in kind of a big data background has probably dealt with Uzi, or if you're not even from the Hadoop era time, maybe you're kind of you've more recently played around with something like Airflow, or more recently there's been Daxter as these kind of like workflow orchestrators. And the basic thing that all of these technologies are aiming to do is that we're ultimately trying to kind of basically put these different tasks that happen across data engineering in general into somewhat of a unit that gets executed and gives us the ability to reason about, or essentially reason about how the execution of ordering. So if you think about this kind of like, in fact we have a nice little graph here. There's these SQL operations that happen, and so there's a unit of execution that happens within the SQL process, and then it's done. And then you have another SQL process here. This is like maybe the first one, the second one, and then you have the third one. You can then, when you encompass all of the SQL that happens within each of those like tasks, you can call them, or jobs. Some people, depending on the orchestrator, will call them different things. Will then encompass these things into small little things. So that's what these little parallelograms are representing here in this diagram. And so now that we have these in smaller units, we're now able to actually represent something like the order of operation that needs to happen. So in this particular directed acyclic graph, or DAG, which is a very popular term amongst workflow orchestrators, you can run this first SQL task and then run the second SQL task at the same time. They are mutually exclusive. They can run independently. But this third task here actually is dependent upon these first two tasks completing. So this task now in this particular DAG needs to wait until both SQL Query 1 and SQL Query 2 are executed. So having a workflow orchestrator gives us this ability to, like, instead of having to like manually run things or run a script that does some sort of weird check to make sure that SQL 1 is done, or you have to do some more all these special things, like this is all actually something that gets managed by a workflow orchestrator. It basically has these abstractions called tasks, so that you can kind of model the order of operation and the order of execution for all of these different tasks. So that's at its core how I kind of see workflow orchestration. And these tasks don't have to be SQL. They're very much commonly SQL in a context of Trino, but these can be things like Bash scripts, or these could be Python scripts, or these could be interfacing with spinning up some Kubernetes cluster. These could be a lot of different things depending on what the workflow orchestrator is capable of handling. And so in the context of Trino, if we just think about just what Trino is doing and what task we need to essentially orchestrate, it's generally going to be thought of, SQL, but then you could also think of like the upstream or downstream changes of like, prepping the files, making sure there's schemas available and things like that. So, so that's kind of my take on workflow orchestration. I'll kind of open this, maybe I didn't cover everything, but like, how would William, how would you summarize workflow orchestration? I'll pick on you first, and kind of, what's the goal here if you were to summarize?
Yeah, I think your explanation is very good. And I think besides the job workflow orchestration feature, there is another important feature for workflow orchestration nowadays. I think the feature is called to orchestrate the resource. For example, there will be a lot of SQL queries to database, for example, Trino DB. And there will be a lot of SQL jobs at the same time. And then actually the concurrency will not be, for example, 1,000 or 2,000. Perhaps you only have the concurrency of the Trino DB only, for example, 100 or only 10 or 20. So how to control the concurrency on your lot of SQL jobs? That's one feature, the important feature for the orchestration tools. That means you can control, you can create, we call the connection pool, something like that. And you can set the connection pool, for example, only 50 queries can enter into the Trino DB. And when the SQL job is over than 50 jobs, and then we will order by the priority of the SQL tasks, because every task in orchestration tools, we will give them a priority. Then you can control the whole workflow to run in a better environment.
Yeah.
So that's another feature, I think.
So this kind of gets into, you mentioned priority. And so I remember a lot in the Uzi days, we actually had like different priority queues. And if, let's say you had, let's say there was like a user priority queue, or maybe something that faced end users, you would want those to have all of the compute. And then maybe there were batch operations that were not human facing that would, kind of could take longer and be delayed. So you're essentially adding an abstraction that enables you to not only kind of be cognizant of what resources are available or not available, but then who gets those resources, what either groups of people or individual users are able to, like, let's say, get priority or special treatment, and which ones need to wait. And primarily, you'll try to prioritize when a human's waiting for a query, rather than, if there's a kind of automated task that can run whenever nobody's running anything, those will get lower priority and get bumped in the back of the line when needed, right?
Yeah, something like that. Yeah.
Yeah. Cool. Cool. Yeah. So, I mean, and that's, and I think it goes even further than that, right? There was another one that I thought of as you were kind of explaining, that possibly, there's these also being able to, when you have these things split out into different tasks and split out into all of these different, you can start monitoring and actually get a better sense of the state of what's going on in your system. And I think this also gets very much into an important aspect of knowing, when you're at a high threshold and when you're getting too close to having these problems, right? Being able to detect and try to, in advance, increase those resources and increase that availability to anybody who's watching this thing. I think that's yet another kind of element that workflow orchestrators are incorporating more and more nowadays to make it a much less stressful thing that engineers have to carry on them, like thinking, oh my gosh, all of this things could happen. Well, if you set enough kind of monitoring and orchestration or sorry, not orchestration, alerting in place and things like that, you'll be able to kind of sleep soundly knowing that, okay, this system's going to tell me when something's even like close to bad, or at least give me some warnings. And so I'll be able to like avoid any kind of like high, peak or that kind of hits us all of a sudden. Hopefully I'll be able to kind of pre-detect when this is going to happen, and I'll have data collected from previous, months and years of when our peak times are going to be, so that I can prepare and kind of, counter any initial blast of traffic that we'll have. Is that also kind of another area that orchestrators are really kind of starting to improve?
Yeah, of course.
Okay. Yeah, great. So this gets into another question then. So one of the core use cases that when you think about, needing an orchestrator, is kind of, a lot of people think about it from the data warehousing perspective. Trino kind of doesn't necessarily, Trino connects to data warehouses. We have a Redshift connector. We have all of these different, Redshift. There's a Snowflake one coming down the line, and then we also have one of my Teradata as well, and a couple other that I'm just not like spacing on right now. But you think about workflow orchestration from Hadoop days all the way, to even just before that, you're thinking generally of like a warehouse, right? A kind of like a warehouse flow where you're trying to stage multiple pieces and bring them into one location. But nowadays, that location kind of is shifting between, just putting everything into a warehouse, but the central kind of copy that people have from a cost perspective tends to be in a data lake. Does workflow orchestrators also kind of like fit in the same model that they were for our warehouses as they do for data lakes these days?
Yep.
I'll still pick on you, William, if you want, or if anybody else has any thoughts on that. Where do workflow orchestrators fit for data lakes?
Let me answer the question first, and
Yeah,
others
sure.
can answer. You have other ideas. And actually, I think somehow data lake is more like more powerful data warehouse, because you have to extract data from different data sources. For example, from Workday or Salesforce or something like that. And also, you will have a lot of ETL jobs in your data lake. So, in my point of view, there will be more and more SQL or other tasks in your data lake. So, if you want to handle the whole ETL things to run in the right order, you have to build something workflow orchestration tools. And I think in data lake or in some we call it real-time data warehouse, you also need workflow orchestration. There's not only nowadays workflow orchestration tools not only support batch job, but they also support streaming job. For example, Spark streaming or Flink streaming. Yeah. And from streaming, from one streaming job to the other streaming job, perhaps the one streaming job just load the data to Kafka, and the other extract data from Kafka. So they also have some dependencies, but they are not triggered by the job ends, but they also have a DAG task in order, because the data will first go to the first Flink job and then the other Flink job. So I think that's why I think we need a workflow orchestration tools.
Would you say it's actually more important in a data lake? Because essentially data lake has a lot more disaggregated technologies that kind of are interoperating on the data lake. And so because you have more variants of tasks, you end up needing actually a workflow orchestrator that can handle a much wider variety of not just SQL, right? It's not always going to be SQL. It's going to be so many different potential things that need to keep that data lake alive and breathing. Does that make sense?
Yes.
Okay, so it's actually not just what we did with
technology are used, I think.
Yeah, I mean, it's getting more complicated, right? The whole data landscape is adding more options, which gives you a lot more flexibility in terms of how you do things. There's a lot more, but so it's definitely harder these days to kind of have to know what to choose. But you like if you think about it like a Lego set, I think about it like this a lot of times. The data scene back in the 80s was like a very small amount of Legos. You just had, the 4 block and then like an 8 block, and you just built those on top of each other. Now we have like all sorts of new shapes of Legos that we have, and you have all this opportunity to build it in so many different ways. The problem is that, once you have all these things, and let's say you want to build it in all these certain ways, making things work like they're one unit is kind of the part that the workflow orchestrator is now starting to take responsibility for, and trying to make it like a single stack that runs seamlessly together, essentially being the glue that gets all of these different Lego pieces together. You're the stickiness that pieces these things and makes them happen and work in a consistent way together, right? Is that like going with what you're thinking of it?
Yeah. And actually, more and more developers just develop their, I think, their jobs on data lake, not only SQL but also Java, Python, Erlang, or Go, or something, or Spark, or something like that. So you have to handle them all in one place. So that's orchestrator.
Got it. Well, let's, so we've talked about what workflow orchestrators are in a kind of more generic sense. Let's hop right into DolphinScheduler. David, since you're the chair of Apache DolphinScheduler, and somebody's going to come up to you on the street and ask you, hey, what is it that you're working on? And what are you all doing with DolphinScheduler? How do you explain that to them if in a couple sentences?
DolphinScheduler is a modern data workflow orchestration tool. What is different from other orchestration tools is because we provide a powerful user interface. We dedicated to solving complex dependencies in the data pipeline, and we provide many types of tasks, such as Spark and Flink, Python share, or we provide many data source, such as Trino, Presto, or other data source. So we wanted to make every type of jobs available out of the box. So
this isn't. Can I ask you a quick question? So when you say out of the box, like, and all these tasks are, these aren't just tasks that are, if you think about like Uzi, for instance, Uzi was very much like only handling jobs that were happening on HDFS. You're talking about tasks that could be literally like a shell command, or it could be, I've seen a couple on your website actually that that interface with Kubernetes or Terraform and these types of tools that do, CI/CD scaffolding and things like that. So this is much bigger than just like big data orchestrator. This is dealing with a much more generic sense of types of tasks that you can handle. Is that correct?
Yeah, correct.
Okay.
Yeah, that's great. Yeah, and actually,
Yeah.
what we want is create a developing platform for the big data developers, and they just can edit their SQL or Shell or Python or Kubernetes or Spark, any big data code on Apache Dolphin Scheduler, and
Okay.
then they can arrange them into the DAG job, and then they can run in the DAG. Then the workflow orchestration will do the other things. So
Okay.
that's what we want, is to let people develop big data program easily.
Yeah, it makes a lot of sense. One thing that really sticks out to me is this last line, the powerful DAG visual interface. So I know we've had visual interfaces, but particularly, so even Airflow has like a visual interface, but you all are particularly focusing on this drag and drop first notion. Could you dive into why that's so important and what use cases you want to enable on drag and drop?
Yeah, actually, it's a very interesting, because I think the main user of a Dolphin Scheduler at first is the data analyst.
Hmm.
It's not a data engineer,
Mhm.
So, there's many data analysts. They just know SQL, and they for example, they can write SQL on Trino DB, or they can write SQL on Spark SQL or Hive or something like that, but they cannot let that SQL run every day in some order. So what they need is to want some tools to just they can use to create all workflow with no code.
Mhm.
So the
Yeah.
first version of Dolphin Scheduler is to just you can drag and drop, and then you can write a SQL or Python or something or Shell in the I think it's a text box, and then you can create the job and trigger in dependency, just drag from one task to the other, and
Mhm.
then the whole workflow will run. So
Gotcha.
that's why Dolphin Scheduler is quite different from Airflow or Uzi or Azkaban.
Gotcha.
And yeah.
So the goal the goal kind of the philosophy I should say, like the kind of core philosophy is that you're still trying to provide the similar APIs that preceding the preceding orchestrators have done in the past, so that engineers still have their same tools, but you want to take off some of their responsibilities by offering yet another low code or no code type solution that enables them to basically just interact with, hey, I have this function that, let's say, a data engineer even wrote, and they can reuse this same script or this same kind of modular piece that is very specific to my organization or my team, and I'm going to reuse this multiple times. So the data engineer's job starts at defining that, writing the code initially, but then after that's been defined and tested well, right, then you can reuse that as kind of this piece that is now what an analyst or a BI engineer or any person that's kind of wanting to facilitate and make the data workflow happen, they can now define that once those initial kind of building blocks are created, and they essentially build that workflow themselves and can manage it and do all of the visualizations that they'll be able to do through the UI. Is that kind of the philosophy and the core driver for Dolphin Scheduler?
Yeah, and actually we want more and more people to use big data tools, not only engineer, but also data analysts and other people who can use big data quickly, I think, or more efficiently.
Yeah, I totally think I totally agree with that. I think that is partially where this whole concept of data mesh. I'm not sure how popular this is in China, but here in the States, and we've been really diving in on this concept, popularized starting from ThoughtSpot. I almost said ThoughtSpot. ThoughtWorks. Which was popularized by Zhamak Dehghani. It's this kind of idea of data mesh, so self-service kind of layer that brings back to not just necessarily even analysts, but you think about software engineers that are working in a particular domain of your company. They're providing some sort of services around the project, and all the way from the web interaction that you get with the customer, all the way down to the back end services that they're doing. And then what we had traditionally done is centralized everything to some data team, but now data mesh is a way that we're trying to actually split that out and bring back some of the responsibilities back up to the software engineers, the data analysts again. And doing a workflow orchestrator in this way, I think, is a very kind of complementary story, where you're giving that capability back to end users and giving more self-service capabilities, so that they're also able to kind of have a say at the table of how this data gets set up. And it's not getting rid of data engineers by any means. It's just it's kind of taking off some of those those overlapping tasks that data engineers literally had for literally maybe 15 years now, where they have been, constantly centralized and having to take all of these requests from all these different end users and do it for everybody, right? And so therefore nobody was getting their work done. This is a way of optimizing that workflow and giving everybody else that responsibility back and that autonomy, essentially. So very, very interesting. Very interesting. Great. Well, is there? Do you want? Before we hop on to kind of more details about how DolphinScheduler works, is there anything in terms of the definition or what DolphinScheduler is that you want to cover that we may have missed?
So I think in one sentence, DolphinScheduler is a distributed and workflow orchestration tools with powerful DAG visualization interface. We will just talk about the DAG interface, but actually DolphinScheduler has another feature. We call it the high availability and high performance, because we just design with the architect with multi master and multi workers. So the performance is very well, and it can just support. I heard some users use DolphinScheduler to support more than 2 million tasks in one day, and typical users are more than 1 million tasks in one day. So the performance is really good. So I think it's another feature of DolphinScheduler.
One thing I think we forgot to ask about DolphinScheduler.
What's that?
Why is it called Dolphin? Who named it?
Oh, yeah, that's actually a good point.
We love Dolphin very much, and Dolphin have 2 brands. The left brand and the right brand, and just like Apache DolphinScheduler is have many worker and many masters. So Dolphin didn't sleep, right? And he just swim all the time. Sometimes the left brain is sleeping, and sometimes the right brain is sleeping. So Apache DolphinScheduler is something just like a dolphin, because it's very smart and it never sleep, because it has many masters.
Wow.
And
I
it's
I
a very
really
nice
appreciate that. I really appreciate that analogy. And dolphins are cute, right? Like
Yeah,
that's another good aspect of it. But now that you bring in I actually did not know that about dolphins, and that is a really great analogy. We actually love animal analogies here. In fact, we've started to name a lot of our projects after different animals. Like we have the tardigrade, which were these like microscopic creatures that never die. They regenerate and can basically come back from the dead. And so that was like our task that would die. It would basically regenerate and come back. There's also, hummingbird. It's another project where the hummingbird is these really fast and very quick and flexible and adaptable, which is now our next query optimization techniques. So I think the animal parallels and amazing things that we see in nature, modeling those after things that we're trying to do kind of in big data and data workflows and systems. It's always really fun to make those analogies. So anyways, that's kind of an aside thing, but very cool. I like that a lot, that analogy now. So high availability, I think that's not anything that's too foreign for anybody that's, working with big data. Even we don't have actually high availability with our coordinator or anything like that. But we do have now, especially with fault tolerance capabilities, abilities to kind of support some of these fault tolerance capabilities from that. And then for the high availability from like an actual availability perspective, there's all these other things that we've done in the community to kind of make that available. So I don't think that that's a foreign concept. It's a very much like thing that we've come to expect on the big data side. So it's great to know that DolphinScheduler also follows in that. And there's a bit of a thing that we're going to cover in a little bit, which is this monitoring and metrics stuff down further, and as well as the kind of resource dependency pieces that you were talking about before. So we'll hop into those downstream. But I really do like this kind of picture that conceptualizes these big differences of again, high availability is a huge one. Plugin based is saying, we cover not just the things that, older ones used to cover, we cover a lot more. And drag and drop first, I think, are the big differentiators. And then this workflow platform is going to be, I think more standard of what people come to expect with other workflow things. But it'll be interesting to see the ways in which you've kind of made your platform fit into this user centric kind of design. So I think that was a really good overview. Thanks a lot for kind of filling us in there. We have before we hop on to the next thing, hello Ashish Stein, thanks for joining the broadcast today. Nice seeing you here. And then we have a question from Mateus. And I don't know if that's actually your whole first name. Maybe I should say Mateus dos Anjos. What are the main advantages of using DolphinScheduler versus Airflow and or DBT? Mateus, we're going to, in fact, actually, I think that's down here. Let's quickly get to this first question of, does DolphinScheduler have a computing engine or a storage layer? Because I think that's going to be something that I'm, certain orchestrators have these capabilities sometimes that you can even offload some of the compute onto the orchestrator itself. So I'm just kind of curious to know, what is underneath the hood of DolphinScheduler? Does it have a computing engine? Does it store data, or what does it store?
I want to share this first. Yeah.
Okay.
Yeah.
Take it, Jay.
Yeah. Just like the Trino do not own the data, DolphinScheduler also do not own the data too. It's just the workflow orchestrator, and the responsibility of the DolphinScheduler is just trigger and run the workflow. Yeah.
Okay.
It must make sure the workflow and the task run on the time as the user set or as a developer set. And the second thing I want the DolphinScheduler responsibility is it must to run the test only if all the conditions are met. So we cannot run the single or the standalone task, at least the upstream tasks are all done. And I think the workflow orchestrator is also the important thing is the tolerance. It means we have the retries and the alert mechanism to tell user when they get wrong. So, sometimes DolphinScheduler even do not calculate the task in their own. It will send the request to the computer or the database like Trino and tell Trino to calculating the data. Yeah.
Okay. Oh, okay. Yeah. So that makes sense. I think so. Basically, you're saying that there is no storage layer, just like Trino, but it does have a very advanced computing engine that kind of makes a lot of these kind of decisions and for running the orchestration. So it's mostly all things in flow and in memory kind of stateful management. Is that?
Yeah.
Okay.
Yeah.
Okay. Cool. And so getting back to Mateus's question here, I didn't want to keep him waiting for too long. So, if we look at Airflow and DBT, I'll just put in my little spin on like where I see DBT. DBT to me is like a SQL and now Python template manager that also can kind of abstract different pieces into like kind of these task type things, but DBT has a very specific goal in that you're trying to test and validate transformations, and that is it. That is like so I think that like and when I say that is it, that is a huge piece of like making sure that the data quality is correct and all of these other things. But DBT is not really trying to make sure that, more general things are happening, like, things that are happening in system A then go on happen first, and then system B kicks in right after system A is done doing its processing, and then system B and D, will take over once system B is like doing all of that stuff and looking at the larger scope is not what DBT is trying to do. DBT is very niched in and focused in on like, how do we make sure that like this change of data, this transformation that happened is happened and is correct, and we have it tested, we have it documented, and we essentially make this kind of, essentially it's making those transformations much more atomic. And so that is a very not tangential, but it's like, it's very, I would say, different from the goals that Airflow and DolphinScheduler. So moving DBT kind of off of its kind of in its own camp, I wouldn't say that it's a it's a apples and oranges more comparison. So Airflow, though, I think is a much closer one, and I'll give this one to any of you. I know you all answer this question a lot more exclusively on yours. So most people these days, when they're working on a workflow orchestration, are using Apache Airflow, I would say, but there's always trade-offs when it comes to all of these systems, and so we covered, I think, one of the biggest ones with DolphinScheduler, which is I would kind of summarize as a user-centric approach, but there's probably more to it, and I want to dive right now into that. So anybody want to kind of talk about where the big value add, and it can also include what I just said, the whole user centricity. But why don't you all kind of walk us through, if you're on Apache Airflow, what is the motivation for looking into DolphinScheduler?
I think the most important point of the workflow orchestration tool is the scalability. But as far as I know, most of the workflow orchestration tools don't perform well when the tasks are executed concurrently. That's why we reinvented the wheel after using Uzi and Airflow. We use the decentralized multi masters and multi workers. We didn't have no no single no single
Bottleneck.
no single point of failure.
Okay.
So the first one, DolphinScheduler provide a high performance than Airflow.
Mhm.
So the DolphinScheduler is 2 times faster than Airflow in some tasks. And the second point I think is easy to use. I think our product tools should be very simple and very easy to use. That's why we called DolphinScheduler before we before I enter into the Apache incubator. We called easy scheduler. When we wanted to make the orchestration tools more easy for new users. Usually, this is a barrier for new users. The last point is the scalability. We have made a very good scalability. I think we integrated with Trino DB very well. We we refer the SPI machine term from Trino DB. So we can integrate with many data source. For now, we have supported more than 20 tasks, such as the shell, Python, Oracle data source. And the user can and the user also can easily to expand their tasks by themselves. We provide plugins API, so they can very easily to use to expand their new tasks very easily.
So the takeaways that I'm hearing is like that, still with that user centricity, right? Trying to very much make it bringing more people into actually using this. Performance is definitely an element. Now, one of those things about like just talking about performance or showcasing a benchmark, there's always cases used like case by case basis. The thing I always recommend people, even when I'm talking about Trino performance versus say Spark performance or something, you always just need to try it when it comes to performance. A lot of people want to see benchmarks, and you could the bad part about benchmarks is you can always flex a benchmark to basically do whatever you need it to do. What's best to do for anybody who's actually curious about performance for their workloads is to actually try it out. And so that's always one of those things. But it sounds like the way that you're trying to tackle this performance issue is really by taking it from a scalability and kind of almost MPP type method that we even use on the trying to basically make it as parallelizable as possible, as well as fault tolerant, right? So that's something that we've done in the Trino community that's worked well. So I am very interested to see how the Trino community, as they start to adopt this, and start to trial DolphinScheduler, how successful that they are and what performance they are seeing. That's always like a really good indicator to hear from the community. One other thing that I'd like to point out that I noticed was when you go to the Apache DolphinScheduler GitHub, you can go see just how where the stars are. They're just about short of 10,000 stars on GitHub, and I know that's a somewhat of a vanity metric, but it is always really good to kind of see to what level people are focusing or tracking. And this is actually, currently above where even Trino GitHub stars are. So it is a very popular project, to say the least. And when did DolphinScheduler actually kind of like, what's the first commit here on DolphinScheduler? Let me see if we can, if I can even go back to that, or if you have a tag that does that. What was the very first release? We have any of that? Let's see what the 1.0 2019. So you all have been around maybe there was a slightly earlier commit than this, but the earliest version that you have posted out here is like 2019. So that's where we at today. We're pretty close to this March value. So you're about 4 years in, and you're at 9.8K stars. So that's a really good trajectory and growth model. So there's a lot to be said about. There are people that are very interested in this. There's a large community. I imagine it is largely, would you say a good chunk of it is in China, or is it pretty well distributed across internationally?
Actually, many users are in Asia, for example, China, Singapore, Japan, and something like that. And some users are in Europe, UK, and Germany. And now we just have a very small user in United States. So that's we just want more people to know DolphinScheduler.
But I feel like that's interesting, right? It's interesting from a US perspective that this hasn't taken off, probably because there just hasn't been a marketing effort yet in the United States, and this is you all starting it now. And so that's why I think it's always interesting to check out kind of projects that traditionally haven't been pushed into a particular area, particularly the US in this case, but have had success in many other kind of geographical regions and countries in those regions. Because it sounds like you all are well on your way to gaining a lot of adoption across particularly Asia Pacific, but then even a couple other areas outside of that. So, for those of us that are in the US that have only been hearing about Airflow and Daxter and maybe even Prefect, that's been the primary three that we've been kind of getting put in front of us. But now I think like having so you're like, what's the other one? Why should I look into this? Well, if you look at the success that DolphinScheduler has had in other communities outside of the US, it's kind of very telling that this is an exciting system, and it's something interesting to take a look at. So I really hope to see that, as kind of people start using it, that it'll be a good indication very quickly, what people in the US actually are looking for, and maybe some more of the understandings around this. So what's really exciting today is that if you do want to play around with it and just get your feet wet, the demo that we have today was added to our Getting Started repository by Jay here. So we're going to cover that in a second. But, getting back to Mateus's question about, Airflow versus this, it sounds like if you're wanting to get your users a little more involved and take some of the pressure off of your data engineering team, that's a very good motivation. Also, that DolphinScheduler really has this performance in mind, and so whether that will what that will translate to specifically to your workload will of course always depend. But what I think is really good to kind of like try to jump in and figure out, is the performance good for us? Obviously, the user applicability and low code kind of capabilities are very much there. And I think that's something that's interesting enough to me to kind of make a more self-service platform, especially if that's what you're going for. And it's becoming much more popular of a notion in the US as well. So that gets me really excited about DolphinScheduler myself. And all the things that you mentioned too, David, like are very, very great. Kind of the engineering rigor that goes into building these systems out is nothing to be overlooked. Great. Anything that I missed and kind of piling on there?
I can give you an example, and for who will use DolphinScheduler instead of Airflow. Actually, I use Airflow before, and I have more than 30,000 tasks, and I found that at that time, when I was using Airflow, I found that the performance is not very good, especially more than, I think, 20,000 tasks. So I have to divide my Airflow cluster into many small Airflow clusters. So I have more than 10 instances of Airflow. So that means I have to divide a whole picture of a DAG into many pieces. That at that time I didn't know DolphinScheduler.
Yeah.
And then I found that DolphinScheduler can support very good can support
multi-tenancy,
huge numbers of tasks.
Yeah.
So that's why we just migrate Airflow to DolphinScheduler. So I think if the user's task is more than 10,000 tasks, I think you can try Apache DolphinScheduler, because it's more easily to handle all the things.
That makes sense. Yeah, and so it's not even just this user capability or the kind of just performance on each individual task. You're saying that it's the aggregation and starting to kind of scale up, especially the fact that it sounds like DolphinScheduler is really trying to push the limits of what gets supported. So as you support more types of tasks, right, out of the box, and you make that available to more people, people are going to want to use the system more naturally, and they're going to want to ultimately tax it out, right? And so having that ability to not just scale for a data-centric type of use case, but also to scale out for maybe software engineers could use DolphinScheduler for some of their, integrating some of their builds or testing or capabilities or things like that, right? Like there's more than, it sounds like DolphinScheduler could be a much more generalized workflow orchestrator. And when you start to tap into those type of use cases where it's not just about data, it could even be more about software iteration and things like that, you would definitely want to have something that can handle that type of scaling out and being able to deal with larger workloads like that. So makes sense. Okay, one last kind of thing I want to dive into on DolphinScheduler is particularly this one that we were talking about, where anytime you're doing an orchestrator, right? Like the orchestrator itself is it's great whenever things are going well and it's enforcing that this runs when this runs and then that will run after these things runs, but then something will inevitably fail along the way. And I think it's really important, almost as if not more important, how an orchestrator deals with failure than how it's dealing with the good flowing operation. And so I kind of wanted to just dive in, how does DolphinScheduler deal with failures? Like, what are the abstractions that you all include when things go wrong in these subsystems that it's monitoring?
Jay or David, or do you have any other ideas? Okay, I can answer this question. Sure. Actually, DolphinScheduler has many master and many workers, and when one of them are failed, for example, workers are failed or masters are failed, and then the other we will rebalance the whole job and rebuild the environment for the failure worker or for the failure masters. So theoretically, DolphinScheduler can I think can restore itself. You needn't to do anything, and the whole cluster will work well. And if some fantail error happen, for example, there will be no any there will be no any there will be no if there are no masters alive or no workers alive, then there will be send an alarm by email or by some alarm API to you. So that's DolphinScheduler itself. And sometimes if your job is failed, for example, ETL job or Python job or Spark job failed, and we have several kinds of solutions. The first solution is just a retry. In each task, we have retry times, and you can set the retry times. For example, you are using Hive. Hive sometimes you cannot select something very successfully because of the
otherwise, it would just indefinitely keep retrying, and then you would just be in wasting a bunch of resources and going in circles, right?
Yeah, and you can retry several times, and then the task will fail. And the second, when the task failed, the whole workflow will fail, and we have some alarm API, and you can receive your alarm message by email, by phone, or by Slack, or by something like that. And it's very easy to implement by our SPI. So I think that's the whole story of failure.
It looks like there's also, in the same way, again, this kind of gets back to this user centricity, but like being very focused on who gets those. Like it's a very configurable about who gets those message in what case. In terms of you have groups of people that should get a signal if something is successful or fails, or then in this event. And so there's a lot of knobs and capabilities that are baked into DolphinScheduler that enable you to essentially customize the way those notifications and those alarms work, so that the right people are getting notified when the right events happen, if that makes sense.
Yes. Yeah, cool. We have different alarm and warning groups. Yeah, you can define that.
Yeah, and especially this is even more important when you start, getting into these orchestration workflows that include people that are not necessarily part of the data engineering teams. You might actually want to include, people who are building these workflows. Hey, maybe whoever builds a workflow, those are the people that are supposed to be notified, not the data engineers first. And then if in the event that something more cataclysmic happens that's affecting everybody, those notifications need to go to the data engineers to fix the platform and what's going on in there. So that's a very, I thought that was a very interesting feature here of how the level of customizability that you have to actually implement not only the type of notification, but who and what in what cases do these groups of people get notified. So it's very cool, very cool. I like that capability. And then finally, on the monitoring aspect, right? If we want to understand our system better, right? Know thyself is a very important piece when it comes to seeing this. And because the workflow orchestrator has so many cross-cutting concerns across your entire platform, it's actually a very valuable tool to be able to monitor and see. It's a kind of a good indicator of health of a system when you see that things are flowing well, and that because ultimately you could have a lot of metrics on the systems that the orchestrator is talking to, right? That Dolphin scheduler is talking to. But if any of those systems are having problems, a lot of times those issues will also, you know, bubble up and show up in the monitoring system in Dolphin Scheduler. So this is kind of like having a monitor to be able to look at the holistic health of your pipeline is actually a very like good bird's eye view to kind of see what is the health of my platform today, you know, of all of these pipelines that are running through my system. And so what goes into the design here to make sure that this is also digestible to, you know, people that are not necessarily part of the data engineering team, or is this only for the data engineering team's eyes, right, to see this level of detail?
Right. Yes. We want to make the engineer to know what happened to their Dolphin scheduler system. When you log in, you can find that the status of the master service or worker service and the database service. You also can find the audit log. You can see many metrics in the Dolphin scheduler. Especially if the master server die or worker server crash or die in the execution, you will receive an alarm in time. The alarm can send through by mail, PagerDuty, and many other alarm tools. And if the master server die or crash, other alive master server will take over his responsibility to and we will take his responsibility to make the workflow run normally. So we designed the monitor model for maintainers, for the Dolphin scheduler maintainers.
Got it. Okay, so in this case, it's actually less focused on trying to make the monitoring available to everybody. This is more trying to make sure that like the data engineering team can holistically understand the health of the system and just take at a bird's eye glance see what's going on. Does that because in my mind I was thinking it might be more about giving visibility as well to, you know, anybody who's using it, but it sounds like it's a little more specific to data engineers or whoever's running the platform. Is that correct?
Yes, you are right.
Okay. Cool. All right. So yeah, that pretty much sums up like all the questions that I had around Dolphin Scheduler. Is there anything else that before we hop onto the demo, is there anything else that you know any of you want to kind of cover that we didn't cover around Dolphin Scheduler, or kind of last minute conclusion on what we should say in terms of that? Because I think we covered a pretty good amount. So you don't have to say anything here, but if there's something we missed, I wanted to give you all the opportunity.
Better when you are using a data lake, I think a Dolphin Scheduler is a better choice.
Yes,
because you have a more tasks and more workflows.
Yeah, kind of what we had mentioned before, right? If you're dealing with something that interops with multiple systems and needs.
I cannot hear you. It's my. Wrong?
Can you hear me now? Am I going out?
No.
Cole?
You're here.
Oh, am I? Okay. I don't know if possibly could be the thing. Can you hear me now? Okay, I'll get it from Cole. Okay, so I might be an audio issue on your end, William. If you can, Cole, if you can reply to William and let him know it might be his audio. Okay, so So basically,
Okay.
what I was going to kind of mention was that let me see. I kind of lost my train of thought there. Give me a second to get back here
The
for a
AV
second.
issues derailing things is a
Yeah,
long storied trend.
Yeah, always happens. So the basic thing, was getting back to data lakes, right? So data lakes are usually deal with interoperable systems, and with that, you're going to have a kind of alphabet soup of. And what I mean by alphabet soup, for those that don't know that idiom, is there's a lot of extra small individual services that are going to be running in this data lake ecosystem, and having a lot more out of the box support, having a lot more capabilities to scale up the amount of tasks that you can actually run with this is going to be all the more crucial in the data lake, even over a much simpler, smaller data warehouse set of pipelines that was maybe traditional in Hadoop days or in the kind of 90s type warehouse workflow. Much more today in the data lake house kind of workflow, you're needing a lot more sophisticated orchestration. And it sounds like that's kind of where DolphinScheduler is trying to aim to handle those use cases. So great. Well, that's really cool summarization. William, can you hear me now? Are we good? Okay. Great. So that sounds pretty good. I'm gonna let's hop over to demo so that we have some time for that, and then we're gonna run into the PR of the episode. So if without no further ado, to the demo of the episode. Okay, so Jay, whenever you're ready. It looks like let me see. There it is. I will pull it up here. So just to give everybody a bit of a background, the instructions for how to do this. Actually, let me show my screen one more time real fast. In the show notes here, we have the demo of the episodes, and if you go to the link that's set down here, there's a README on how to set up all of the infrastructure that Jay is about to show you. It's all exists in our this repository here under DolphinScheduler, and you just go through the README and follow the instructions there. This is basically after you've already started the services, and now off to you, Jay. So you've already started the services sitting on top of Docker, and you're showing us the DolphinScheduler user interface, correct?
Yeah, that's correct.
Okay. Great.
And we can see this is the DolphinScheduler login page. When we enter the username and password, that's the wrong password. Sorry.
So in this one, it's DolphinScheduler 123 that you have on the README here. Is that correct?
Yeah. That's correct.
Okay.
That's correct.
Cool.
And the first page you enter the DolphinScheduler was the home page. It will show you the basic statistic information about DolphinScheduler, like how many workflow you have and how many tasks today runs and how many workflow today runs and what's the state of each workflow and task. Such as we have the failure and the success workflow. And when you're using the DolphinScheduler, the first thing you should know and remember is what is the concept of the DolphinScheduler talent. In DolphinScheduler, the concept of user and talent sometimes will misleading some users. And the brief difference is the talent is for the task runs. It means when the task run, the DolphinScheduler will use the talent to run the task, and the user is only for the web server and web UI. Yeah.
Would it be fair to say that tenants work like groups, kind of like, so if you're in a group that you want to, that are that have a certain set of resources allotted to them. The tenant is more focused on the resources that, let's say, a group of people have. And then
yes,
there's, okay, great.
Yes, and the tenant is one-to-one relationship into your Linux box to run the Dolphin scheduler worker. So when you create a tenant name root, and it will create a Linux user in your Linux box name tenant, name root, and there are another concept to know about users and tenant. Users and tenant are one-to-one relations, so we can assign a tenant to single users. In this example, I assign root tenant to user admin, and this means when we log in to Dolphin Scheduler Web UI, we can create and manage our workflow by user admin. But when we run the workflow or we run the task, we will use the tenant name root to run the task. Yeah, and that is I want to say the basic difference, the basic concept when you use the Dolphin Scheduler. And let's begin to create a workflow in Dolphin Scheduler. In Dolphin Scheduler, each workflow belongs to project. So when we want to create a workflow, we have to create a project. In this case, we name the new project 1 because we already have the new projects. So we create a new project 1, and all the workflow should connect to this project. And when we go to the project dialog, we can see there's a simple statistic for this project, and we can see how many task instance it have and how many workflow instance project have. Yes, and if we want to create a workflow, we can go to the workflow definition dialog. Yeah, you can simply click the create workflow button to create a workflow. Just Dolphin Scheduler said we use drag and drop first to create our workflow. You can simply click the workflow and drag to the canvas to create a task. Our task has some mass form data form to require data form. For example, you can create a name like equal1, and you just equal1, run the equal1 bash command, and then you can save it into the. You can save it and name our workflow, such as we name it like workflow. And that's it. We just create a workflow with one single task, and the workflow name workflow, and the task name equal1. It just run the command equal1 and simply print the 1 in our terminal. When you want to run the workflow, we have to set the workflow online, because we can make sure that all the running workflow is online to make sure the security of the when you develop the workflow. Yeah, and we just simply click the start button to start our workflow, and you can see it already create a workflow instance for the workflow definition. And when we go to the workflow instance dialog, we can see it was the state of this task is success, and we can see the log of this task, and it just simple print the 1 in our log. Yeah, and that's the simple way to.
So
create a
we're still only seeing the workflow definition at this point. Was there another window that you were working off of?
No. When the workflow run, we will create the workflow instance, as you can see.
We didn't see.
We didn't
Your
see
screen is freeze. I think.
Oh
yes.
We can still see.
Okay.
Any other thing.
Oh my God.
So you had just created the workflow. If you want to start from there.
Oh, I will share my screen now.
Okay.
Maybe
yeah.
Yeah.
No worries, and I'll bring it back. Let me see. So, and then no worries. Like, this is why demos are fun, right? Is because they can go like this. So let me see if can you? Yeah, I see your mouse moving now.
Yeah. We can see the instant of workflow is create.
Yeah.
It's just same as the workflow definition line. But
would you mind going to the workflow definition and show us how you run it one more time?
Yeah. Okay. Before we run the workflow, we have to set it online. Yeah, and then we can simply click the start button to run our workflow.
Oh, great. And that's just to protect you if like you don't intend to run a certain workflow, that you can put it into an offline mode to avoid somebody accidentally starting it.
Yes. That's
okay,
correct.
Great.
And then you can see there's 2 workflow instances here, and both of them are success. Yeah, and we can see. Oh, I know that because when I click the workflow instance, it will create a new tag for the Chrome.
I'm sure everyone can imagine the output of the workflow being
one.
Yeah.
Okay.
We can imagine that one.
Sure. Yeah. Okay. That's a simple way to run the workflow in the DolphinScheduler.
Okay.
Yeah, and for the Trino is the Trino for DolphinScheduler is the circle task. We have the circle task here. So when we want to use Trino, we have to create the data source for Trino first.
Okay.
And if you follow the tutorial, we just merge into the Trino getting start repository. You can start a Trino, follow the step, and when you want to connect Trino in DolphinScheduler, you have to choose Trino data source. Yeah, you have to fill some required data form. Just like we have to enter the maybe the Trino path, and the IP maybe is the 12120, and we can simply run the task to test the we can simply run the test to test whether the data source is available. And because I already created a Trino data source, so I just cancel the create process. And when all sets of your data source, you can use it in the
workflow.
In the workflow, yes, in the workflow. Yeah, because the DolphinScheduler was just create a new task, so I have to change to another tag. So sorry.
Sure.
About that.
No worries. No worries. We'll pull it up. Let's see.
Oh, so yeah.
No rush. People can skip forward through this whenever this is on YouTube, so no worries.
Yeah, you are so kind, Brian. Because we already create the workflow. Oh. I,
Again.
yeah. So sorry about that. Because DolphinScheduler will create a new tab for it. It will be more convenient to when you add the multiple workflow. Yeah.
Okay.
We can simply drag the circle task into the workflow dialog and we name it to Trino. And we select the Trino data source and select the data source instance. And sometimes maybe we just put some, put
We
some.
do select one.
Yeah, put some select.
Oh, there you go.
Select. Put some select to it. Oh, maybe this cannot work. I can make some. I can copy some from the tutorial.
Yeah,
This way.
perfect.
Oh, here I can get it. Yeah, it's just select some customer table, and then we can save the workflow again and set it online again and run it. Yeah, that's all. And we can start the you can see that we already the state of the workflow instance is success, and we can query the Trino data source.
Perfect. Awesome.
Yeah, and
very cool.
That's all.
Yeah, that's great. Awesome. All right. Well, thank you very much for that, Jay. I think it's always very good, like for people to see. And I wanted to, actually, Jay, could you pull that up one more time? Now that I think about it, I wanted to. Could you bring up your screen one more time? Because I also want to show all the other sources that you all have. So I think the powerful aspect here. Here, I'll bring this up here. Could you open up a workflow, the workflow definition where it shows all of the potential data sources?
Oh, data source.
Yeah, there you go. New data. Or not necessarily data source, but the what was it? The task type. That's what I meant to say.
The task, yeah. The task.
If you open up where
if
you go to workflow and
workflow.
Then
Yeah.
If you bring that up, I wanted to show the variety of tasks that you all are capable of doing in the kind of drag and drop there.
Yeah. I will show the task.
So I think the really powerful thing, if you look to this left screen right here, this left pane, these are, you have shell here, Java, Python, procedural, SQL, and then, that's the universal ones. If you go and look in cloud, can you open up the cloud one there?
Yeah, of course.
You have ability to, interface with Kubernetes. You have ability to interface with EMR. And so these are just kind of the same way that Trino works, all these different kind of plugins and connectors that you can now set up in a certain way, in a templated way, and then give to end users to drag and drop and pull these things together. I think that user experience is a really big thing, as well as the experience that William was mentioning before, where it's this, very able to scale to multi-tenancy. That makes DolphinScheduler pretty interesting in my opinion. So that's the kind of power that you can interweave a lot of these out of the box solutions and capabilities. I don't know, spin up Kubernetes if you need to somewhere in between there, and then query that new task. Like there's a lot of options here that become capable of that go outside of what we normally defined or previously defined as an orchestrator. So that's I think another really cool element of DolphinScheduler that I didn't want to get undersold with this demo of just showing just Trino. The interweaving of Trino into these other tasks are I think what makes it very powerful. So very cool.
Show the machine learning task. So it's
we also introduced the machine learning task in the latest version. Yeah.
Oh, cool. So SageMaker, if you're doing AWS, PyTorch, you all have Ray in there by chance, or is Ray coming anytime soon? I know a lot of our Trino users use Ray.
Yeah, we will have a meetup with Ray.
Oh,
I think
cool.
it's next month, and we will have that task at the
Awesome.
time. Yeah.
Yeah. So I mean, this gets right into like the crux of what a lot of people are trying to do with Trino nowadays as well, machine learning and AI and ML tasks, right? So very good point, William, to bring up there, and thanks for showing that, Jay. So yeah,
and
so
Jay, you can create. Sorry to interrupt you, Jay. You can just show how to create a dependency between two tasks.
yeah. Let's just to show what that looks like.
Between two tasks, from Echo to Trino, you can link how to create a dependency between Echo one and Trino.
Yeah. I got it. But I have to set it down low. Yeah.
Okay.
The setting the dependency between the tasks is quite simple. You can just click the upstream task and jog it to the downstream task, and
Nice.
then you release your mouse, and the relationship will be created. And
Nice.
when you click the save button, all the information, including the task and the task dependency, will be saved in DolphinScheduler metadata, and the workflow will be created. Yeah.
Okay. Very cool. And
I think
anytime
it's
you
very
rerun,
simple.
Yeah, I think that's and so I would say this user interface is very akin. What reminds me of is NiFi. If anybody's ever worked with NiFi before as well,
I know.
So it had this similar kind of like drag and drop thing, and I thought that's one of the, I think the biggest draws about NiFi, but it wasn't as generalizable and did not have the data focus that DolphinScheduler has, as well as the also generalized focus to make it more applicable to software engineers or data analysts outside of your team. So this is all really, really cool. I think it's interesting, and I hope that more people, as they come up with questions around DolphinScheduler, I'll have all of you are in the Trino Slack channel, so you'll be able to answer any questions that we get from there. So very, very cool. Thanks for that demo, Jay. Let's let me see. Let me get back into gears with our final segment of the show, which is the PR. Whoa, I wasn't ready for this. Hold on, let me a second. Okay, so ready for the PR of the episode.
There it is.
There it is. Okay. So while we've been talking about data lakes and all this other stuff, this is kind of getting away from all the cool stuff we've learned about today with DolphinScheduler. I want to talk about, one of these, we were talking about performance releases and things like that earlier in the last releases. And one of the first things that Trino has, did in the earlier days was like I guess we really hedged our bets and focused on orc format a lot in the earlier days of Trino. More recently, there have been a lot of Parquet improvements coming down the line, and what we're starting to see is Parquet is primarily the gaining, I guess, a lot more popularity in data science and machine learning communities, and so that is kind of becoming the more de facto standard outside of just kind of data engineering teams, I would say. And so we really do want to start putting this like larger investment into Parquet. And I wanted to showcase a couple of these performance improvements that came around specifically our Parquet files. Ranak Mororka, he's a maintainer and also just contributor, long-time contributor. We had him on, I think, episode 11, where he had implemented some of these performance benefits around dynamic filtering when he worked at Qubel. He's now currently working at Starburst with all of us. So anyways, he did a lot of work on the Parquet files. So I linked multiple of these PRs. So it's actually a multiple PR of the episode, but they all are kind of covering very, very similar overlaps of basically just, rescaled decimals, optimizing the Parquet reader, essentially just trying to improve the read performance out of these. And again, these are one of those individually it's a very small kind of change, but then you add in the fact that we've covered all of these timestamps across one file format, and you do this on multiple times on kind of improving the performance. We're really getting to the point now where there's not as much of a distinction between the orc performance that there was of the Parquet performance. And so that's been really something we've been intentional about, just due to the fact that Parquet is really a very central open file format that people are using around machine learning and data science. So we want to make sure that that is very fast standpoint.
Yeah, and this has been happening every release. I think it's probably the most common release note I've had in the last 4 months has been
make Parquet better.
Parquet performance in some variety. It's every time it's Raunak like just making Parquet better, adding like new configuration options, adding marginal performance improvements, and they have to be piling up. So
yeah. So at this point, when we look at benchmarks that have happened, over the time, like there's used to be kind of a gap between Parquet performance and Orc, and that gap has been, getting much closer. Our Orc performance has always been top tier. Parquet has gotten better here and there, but then it was just like in the last year, it's really gotten, because like we've really closed the race there, particularly due to the popularity of Parquet and in these other workloads. And so definitely if you're a very heavy Parquet user, I wanted to point that out and get the excitement going on around that. Let's see. So let me pull in everybody here. So basically, in summary, I wanted to say, DolphinScheduler has a lot of interesting features, in contrast to previous orchestrators that I think make it very much worth checking out. It's very scalable. It has a lot more, again, like this kind of user focus that I really enjoy in terms of the user experience that expands outside of just the data engineering team and feeds into this kind of goal that we're trying to achieve in data, where it's like much more self-service, right? And that to me is very exciting to see a project like this, finally have an orchestrator that does have those capabilities. So I wanted to quickly thank, all of you for joining me. It's now, I think, 3 a.m. in China right now? We're getting close to 3 a.m.
Go
now.
get some sleep.
So you guys need to go get some sleep. Anything that, so where do people go if they want to learn about DolphinScheduler and about what you all are doing, what the latest features are?
I think right now we call the ops, data ops.
Okay.
Then we just do some features of data ops on DolphinScheduler.
Okay.
And then everybody can use DolphinScheduler and to use GitHub or GitLab very, very easily by using DolphinScheduler, and can them together.
Okay, great. So this is, if you're wanting to check out the website too, it's DolphinScheduler, all one word there, .apache.org. It is an Apache project. You can get to start feeling this. And I think now this is 40 plus types. You guys got to fix your website. So and I don't know if it was Trino the 40th, maybe. But anyways, we should get a Trino logo in here. I didn't know if I saw the Trino one in here yet. And then checking out all the different features, high reliability features, all the things that we talked about today. Obviously, links to their GitHub that will give you a lot of ability to check into the code if you're wanting to contribute. And then they also have a Slack channel, much like Trino, to join in and be a part of that. So all of that is available if you go to the community drop down here and go onto this space. You can check this out, and I'll add all of those links into the show notes. Anything else any of you all want to add before we hop off for today and let you all get some sleep? All right. I'll take that as let's get some sleep. So thank you all very much for joining, and we'll see you all in the next Trino community broadcast next month. Thanks.
Music for the show is from the Mega Man 6 gameplay album by Krzysztof Słowikowski. Don't forget to give us a star on the Trino repository at github.com/TrinoDB/Trino. And for more information on future shows and to find show notes, check out trino.io/broadcast.